So, hello, dear teachers. Today we are going to finish the last lecture in this semester. There's a new things also for you here. And also maybe there's 2 or 3 questions inside in this lecture. So careful and pay attention. The important things here, the name of the things and how to deal with that situation. For example, we have hyperbolic functions. The hyperbolic functions, like trigonometric functions, they are 6 more functions. They have identity, they have derivative, they have a graph, they have an inverse, they have an integral, they have an inverse again, derivative of the inverse, and integral of the inverse. So we have 5 things that we needed here. First of all, hyperbolic, the name, graph, and with the graph you can answer domain, range, limits, you can do it. Then later we have a derivative, then we have an integral. But fortunately, they are not difference or more difference with the trigonometric functions. They have a little bit difference. But the inverse of hyperbolic inverse, they have many things. So today we are going to start with the original, then later we are going to figure out about the derivatives. For example, the beginning, what's the sine and what's the cos? We are reading them as a sinh, sine hyperbolic of x, and cosine hyperbolic of x. So careful, we have hx and hx again. So sinh and cos, these are the basic, as you know, like sine and cosine. If we have and the definition of them is like that. Sine hyperbolic is combined between 2 exponential function, and the cos of x is again combined between 2 exponential function. The difference between them is addition and subtraction. This is the first definition. So cos and sinh are like that. Okay. And sine, we have also tan hyperbolic of x. Tan is equal to what in the previous tan? It was sine over cosine. So here the same. Sine hyperbolic or sinh over cos. Understood? How about cotan? Cos, sinh. Understood? It's the same. How about second hyperbolic? It was 1 over cos. How about cosecant? So the 6 of them, they are the same. How about cosecant hyperbolic? It's 1 over sinh. Understood? There is no difference between them. So here we are. We have a graph, 6 graph, which they are easier than actually the previous one. So I'm going to figure out the function for you. The function, pay attention, because if you control the function, you can control many things. The domain, range, inverse, limit, sorry, whatever you want. So I'm going to start with the sinh. The graph of the sinh, as you can see from here, is like x to power 3. It's like that. It looked like that. So the domain of this function, I think, is easy. Later, I'm going to go back to the domain and range. How about cos of x? The graph is like x squared plus 1. How was x squared? How was the graph of x squared? U plus 1, 1 up, right? It's like that. So you can see from here all these 6. How about tan hyperbolic? It's like a cubic root. Tan hyperbolic, we have tan hyperbolic of x. It looks like cubic root, but here we have an asymptote. We have an asymptote here. We have asymptote there. It looks like tan inverse, right? But here we have 1 and minus 1 instead of pi and minus pi over 2. How about cotangent hyperbolic graph? Cotangent hyperbolic graph is like you can complementarily do it on the tan hyperbolic graph, or you can do it like that. It's like 1 over x, but here we have 1 and minus 1 again. So that's why in your lecture note, if you look at it, you can see both graphs are on the one, they combine together because it's easier for you. And you can see here we have a second hyperbolic, the graph of second hyperbolic. We have a graph such is like that. We have 1 here, and the graph is like a normal distribution. These called normal distribution, like a hill, like that. Understood? And also the final one, we have like a 1 over x cosecant hyperbolic. So the graphs are familiar for you. Maybe just that one is new for you, right? The other are the same. You saw that shapes before. You can compare them. So during the exam, maybe I say sketch the cosine hyperbolic. You can do it. It's easy and compare. Now I'm going to the domain and the range one by one. Tell me about the domain of this function. Sine hyperbolic R, right? Why? Because the shadow is over x-axis everywhere. How about range of that function? Sorry. So range of this function, also you can say R. Why? Because starting from here, 0 to down. Am I right? Understood here? It's easy if you know about the, actually, about the graph. How about domain of this function? R. Hello? Domain? R. Why? Because the shadow is everywhere. How about the range? 1 to infinite. You are right. 1 to infinite. So you can see from 1 to infinite is the range, and domain is R. Again, is R. From minus infinity to infinite. Okay. Third one, domain and range. Tan hyperbolic domain is R, right? G of f, R. How about range? -1, range of this function, good. -1, open or close? Open, well done. Why? Because you can see I'm playing here, no more. Understood. Now, how about the fourth one? Cotangent hyperbolic, domain of that function. R except 0. Okay. So range, any other else? Kaka Mustafa? Range. Yat. Snar. Yalla, bzule. 1 to infinity. Okay. 1 to infinity. Close or open? Kaka Mustafa. 1. Is open. Okay. Any else? Sorry? Minus infinity to infinity also. How about here? How about that part? So union, you can say union -1 to minus infinity. Understood why? Because we have a graph here. That's why. Easy, I think it's easy for you. I'm going to leave these two for you. Understood? That one is clear. Domain and range are R except 0 both. How about that one? Yalla, سريع about generally. Domain R range. Understood? You got it? Understood? It's not asymptote, actually. That one is not asymptote, just like a range. Understood? Good. So we have many things here. We have a table, that table. You saw that one before with a different. What's the difference between them? You saw that one, cosine hyperbolic square minus sine hyperbolic square is equal to 1. But there we have what? In the previous, cosine plus sine, right? So we have a difference, like the property are different in some way, not a lot. So we have cosine square sine square is equal to 1 plus, but here we have a minus. Sine of 2x is equal to 2 sine x cosine x, so the same. Cos, it was cosine 2x, it was equal to cos minus, but here we have plus, is not the same, so careful. When you have cos, the rule will change. How about cos square? That one is the same. How about sinh? The same or not? You know what I mean the same? I mean, in, for example, we say in sine square of x is equal to 1 minus cosine 2x over 2, right? So compared with that one, with the sinh square, you can see there's a difference, right? So it's not equal. The same thing, try to compare with that one, and it will be easy for you. Question. It was new, but it's not totally different. You can figure out the difference between them. Do you have any question, dears? Okay. Actually, we don't need these a lot, but just try to look at them. Now, this one is very important for us. We have the derivative of them. Okay, derivative of them. So, like a review, forget about sine hyperbolic, cosine, and these stuffs. I'm going to review the chapter 3 for you, okay? So, if I have 6 function, if I have sine y equal to sine of x, then second y equal to cosine of x, then back to Jonica. First, y equal to sine of x, then second, y equal to cosine of x, then y equal to tan of x, then number 4, cotan, number 5, second, number 6, cosecant of x. Give me the derivative. The derivatives are equal to what? Derivative of sine? Well, cosine. Derivative of cosine minus sine of x. Okay. Derivative of tan, secant square. That's secant square of x. Derivative of cotan minus cosecant square of x. Derivative of secant tan, you can say secant tan, thank you. Secant tan of x. Yes. Second tan of x. The last one, derivative minus cosecant of x, cotan of x. You know about that one, right? This is the second time. So look at here, I'm going to change it to the hyperbolic. Just look at it. Nothing changed. But here, here, and Nothing. I think it's easy, right? What's the difference? In the previous one, it was the first positive, second negative, positive, negative. It was like that. It was like that. Positive, negative, positive, negative, positive, negative. Now, no, we have three of them. The third one, first, second, till the third one are positive. The rest are negative. So it's easy to control it, right? It's new, but it's easy because you saw that. So that's why you can see from here and you can see from here. Positive, positive, and here's negative, negative, negative. Understood? So for example, if forget about that one. And if you know about the derivative, of course, the integral is the same, right? How? How they are the same? For example, I say integral, look at here, integral second square hyperbolic of x dx. I know second is equal to what? Tan. So second hyperbolic is equal to tan hyperbolic of x plus c. Is the from the third one? Yes. So we don't need a negative. How about cosecant hyperbolic square of x dx? Directly, I'm going to write cotan hyperbolic of x plus c, and I don't forget about minus. That's all. It was hard or not? Just tell me. It was the same, like a review. But h, we add h before the x. That's all. And with the small notes, you know, about the positive and negative cases. Understood, dears? So for example, if I have sine hyperbolic 2x dx, I know that one is direct. So how's the solution? How's the answer? Yalla. Sine is equal to cosine by minus, but here we have plus. So I say cos of h c, right? Derivative of here 2. That's it. The same strategy that we did before. The same, nothing else. Understood, dear? So all these can apply here by just changing the positive and negative, no more else. So that's why I'm not giving you more detail, because the details are easy. You can write down like that. How's the solution? We say is equal to derivative of tan is equal to secant square, right? Then the derivative of the angle. Am I right? The derivative of the angle. So you got that. How about cotan hyperbolic? We know we cannot solve cotan directly. Cotan wala diyor çok halak, the previous one. Cotan, we say cotan or tan, we cannot solve it directly. So we change it to what? To sine over cosine or cosine over sine. The same thing is true for here. If you have a h, so we say is equal to cos, exactly, thank you, over sinh of x dx. Derivative is exist here, because I'm going to use ln, right? Sine hyperbolic of x plus c. Easier than the previous one, because it's the second time you use that. We have a 5, so we need the 5 also, of course. How about square? How we solve that one? We couldn't solve sine square of x directly. Do you remember that? We changed it to 1 minus cosine 2x over 2 dx. Okay, Kaka Muhammad? So in that case, we solve it. How about here? The same. We cannot solve here directly. So how we solve it? How's the rule? We are going to use the rule, the new rule. I told you there's a difference. Do you remember that? So you got to use that one, and it will be easier. Any question? That one is new for you. Actually, that one. That's the new idea for you. I'm going to talk about it. We have e to power x sinh. If you have with sinh or cos or sinh, any one of them, if you have e to power x with the integral, so directly try to extract the function. How? We know cosine or sine hyperbolic is equal to e to power x minus e to power minus x plus 2 over 2. You heard that, right? Right? I told you that. It's the definition. So then multiply them. It will be easier for you. How? So I say is equal to e to power 2x minus e to power 0 over 2 dx. Do you understand why? Because you multiply that one to numerator and I got that one. So finally you will get what? E to power 2x over 1 over 2 minus 1 over 2 dx. Understood, dears? Do you know what did I do? Question? Yes? Because you have e to power x multiply e to power minus x. The bases are equal. We are going to add the exponent. So x minus x and equal to 0, and equal to 1, right? That's why. And you know how to solve e to power 2x. Any question? Dears? Good. It's easy because you saw that one. That one, it was actually, that one's new for you. But here's the clue. Here's the idea. Then you'll get the value. Any question about hyperbolics? Okay. So here we are. We have another 6 more. Again, the graph are important. Again, derivative are important. Again, the integral are important. So here we have what? We have hyperbolic and hyperbolic inverse. Before we are going to inverse, we need to restrict the domain. Do you remember that for sine and cosine? What do you mean by restricting domain? We cut it, right? Why? Why we cut the domain? For example, I say, if you try to find the inverse of that function, we should change it to something like that. Do you remember that? Why we cut it? Why we cut that one? To be one-to-one, to apply horizontal line test, right? Horizontal line test to be one-to-one. Because if the function is not one-to-one, the graph or the function has not what? Inverse. Careful. So that's why we are going to cut the previous 6 graphs. Sine hyperbolic is like that. So we don't need to cut it, right? But cosh, it was like that. Do you remember? So we need to cut them. Understood? So the same thing is true for what? For tan and tan hyperbolic. Here's a graph of second hyperbolic, which is not one-to-one. Am I right? So we are going to what? To cut them, to restrict them. How about the others? Where's the other one? So you can see also the others. Tan hyperbolic, cosh, and hyperbolic. Do you get the idea or not? So we, first of all, we try to make them one-to-one. Then later we try to find the inverse. Okay. So at the beginning, I'm going to sketch the graph of the sine hyperbolic. Here's the graph. And I'm going to sine hyperbolic of x. I'm going to find sine hyperbolic inverse of x. So how we do it? We say that face and back. Do you remember that? Face to y axis, back to x axis. Now it's going to be different things. Face to what? X axis, back to y axis. You can see here. Face to x axis, back to y axis when we reverse. Do you have any question about the inverse? You know how we do it? Hello? Your face is jammed without telling anything. Understood or not? Good. Easy. More easier than the inverse of the sign, right? Just we have like that, we change it. Even you can imagine by like that. We have x cubed, or rasmi x cubed, right? It look like y is equal to x to power 3. And that one what? As cubic root of x. Even you can imagine like that. You can imagine to be easier for you. How about cosh? We say cosh is like that. Now we are going to change it to 1-to-1 like that. And I'm going to sketch the inverse. How? This point is 1. So I have 1 here, right? And it's going to be the face to the axis and back to that one. So I'm going to say the face to axis like that. Understood? Good. So that's how we sketch the graph, and the same thing is true for here. For tan hyperbolic, for example, sorry, second hyperbolic of x, the graph, it was like that. 1 is going to back to be here. So I'm going to change it like that, and I'm going to find the inverse. So from 1 close to 0, so from 1 close to 0. These are important, and I'm going to leave this one for you because they are the same. Tan hyperbolic, cotan hyperbolic, cosecant. Cosecant itself would look like that, the same. Cosecant hyperbolic is like that. Cosecant hyperbolic like that. The inverse also the same. A little bit changing the shape. Understood? We don't need these properties. Actually, it will be more hard for you. We have the derivative of them, and we have the integral of them. These things are the same. Before the rest, do you have any question? Because I'm going to give you the rest to get the information. Any question?